We have all seen the graveyard of college passion projects, the GitHub repositories that start with boundless enthusiasm, building a game engine from scratch or writing a custom compiler, only to sit untouched for 5 years, defeated by the sheer volume of work required for a single person. This schematic maps out one of those extreme ambitions, SexOS. The goal was to build a single address space operating system, or SASOS. Instead of relying on traditional Linux architecture, it would put everything into one shared 64-bit address space, aiming to run 4 times faster than Linux. Building a microkernel from scratch is punishing. You are writing bare metal Rust without standard libraries. You have to manually route memory protection keys at the silicon level. It requires a level of mathematical perfection that quickly drains the energy of any solo developer. When you combine high technical ambition with the isolation of a one-person team, the math is unforgiving. The project inevitably collapses under its own weight. Today, the explosion of generative AI looks like a theoretical lifeline for these dead projects. Suddenly, a solo developer has access to an infinite pool of coding labor. But when you feed a custom microkernel into a standard large language model, it shatters. AI models are trained on standard desktop and web applications. If you ask them to write an operating system component, they hallucinate Linux dependencies and standard libraries that do not exist on bare metal. This exposes why brute force prompting is incompatible with systems engineering. Creative writing allows for approximation, but a microkernel requires absolute precision, where a single misplaced pointer destroys the entire system. Without rigid architectural constraints, the machine simply generates broken code at a faster rate. The creator of SexOS realized that to make the machine useful, they had to move past the generic chatbot and build a structured AI workforce. This hierarchy starts with macro agents, like the codebase investigator. These act as project managers, mapping system-wide dependencies without writing the final code. Below them are the micro agents, or snipers. These are highly specialized, token-efficient agents restricted to single tactical tasks. The ASM sniper verifies hardware instructions. The ELF surgeon maps binary alignments. They have zero conversational ability. They output only strict data. Dividing labor into these narrow parameters eliminates hallucination. The setup mirrors the structure of an elite, heavily compartmentalized software engineering department. How does one human director enforce absolute correctness across this new automated workforce? The answer lies in a single file, the sexoscontract.toml. It acts as a deterministic state machine, serving as the absolute source of truth for the entire operating system architecture. These AI agents cannot negotiate with it. Backed by Intel memory protection keys, the silicon physically deflects any unsafe memory transition, throwing a hardware fault. This triggers the learning loop. The compiler agent captures the error, iteratively recalculating its logic until the output reaches the required mathematical state. By binding the AI to these physical hardware limitations and strictly enforced contracts, generating non-compliant code becomes effectively impossible within the system. The abandoned college dream is now SexOS, a fully booting, functional microkernel. The AI acts as a scaling lever, amplifying the capacity of a single engineer to manage millions of lines of code. Because the specialized agents absorb the mechanical labor of hardware locks and memory routing, the human architect can focus entirely on high-level system design. Engineering feats that once required massive corporate resources now move forward through solo architectural vision. Because the silicon-backed protocol is now the automated gatekeeper, the project can safely open up to the world. A UI designer from a freelance site or a critic on a forum can contribute code, knowing the system will physically reject any input that violates the microkernel's isolation rules. The specialized AI agents serve as the ultimate filter. They ingest these external inputs, reconcile them against the SexOS contract, and merge only the verified code. This suggests that the flood of unreliable AI code in the industry is a symptom of poor system management rather than a technical limit. SexOS shows that a single person can maintain the technical output of a massive organization, as long as they use the hardware to enforce their intent.